Okay, again, just as I was mentioning before, if you haven't tried these, don't watch the video yet. Turn it off, try the problems. They're pretty straightforward, especially if you've written down these 9 key identities or variations of the identities, the Pythagorean identities. And then we're going to use these along with the reciprocal and the quotient identities to rewrite each one of these. The directions say, use the Pythagorean identities and definitions of trig functions to substitute in an equivalent expression for each. So they want an equivalent expression for each one of these. So I'm going to try to make sure I match up with your instructor here. So let's see. All right, well, okay, it's getting started now. So if you haven't tried them, try them first. Okay, now I'm back to them here. All right, 1 minus cosine squared theta. Now if you have these memorized, you know what that is right off the bat. If not, you might have to look over here and, oh, look at that, 1 minus cosine squared theta. This is equal to the sine squared theta. Done. That's the answer. That's all they want. Look right here, 1 minus sine squared theta. Look right here, 1 minus sine squared theta. This is equal to cosine squared theta. That's pretty straightforward. Even straighter and more forward. Sine squared theta plus cosine squared theta. That's this guy here. And now I know they put the sine first. Some books write the sine first. I'm not sure why. But addition is commutative, so it doesn't matter which order they're in. It's equal to 1. So this is equal to 1. Done. Now on the next two, these are not where you can use Pythagorean identities, because you can see that the trig function isn't squared somehow to use one of these. This is where you're going to write them as either a quotient of 2 trig functions or a reciprocal. In this case, this is equal to the sine of theta over the cosine of theta, which is probably what he wants. But it's also equal to the reciprocal of cotangent. Now I doubt if he wants that. This is probably more likely what he wants for an answer. This guy right here. But that's what the tangent is. That's not from anything new today. That's from before. Cotangent of theta. Well, they're reciprocals. I just said that. So this is the cosine of theta over the sine of theta, which is probably what he wants. Or because they are reciprocals, maybe it's 1 over the tangent of theta is what he's looking for. But most likely that. Now it gets a little more interesting. Now we get some tangents. So I'll find my tangent ones right in here. Tangent squared theta equals, well look right here, tangent squared theta equals secant squared theta minus 1. There it is. It's just that simple. Let's see if I can get a better pen here. Next one up. Secant squared theta. Going back here. Excuse me, secant squared theta, you see how it's all by itself here? It's equal to 1 plus tangent squared theta. This is equal to 1 plus tangent squared theta. And there's your guy. Cosecant. Now I'm going to go to the bottom ones here because I have cosecant squared theta. Look at the top line here. Cosecant squared theta is equal to cotangent squared theta plus 1, or 1 plus cotangent squared theta. I'm going to write cotangent squared theta plus 1. Tangent squared theta plus 1. Now that probably is a variation. Let's see if I have it. No, it's right there. They changed the order. 1 plus tangent squared theta plus 1. It's equal to secant squared theta. Okay, just trying to get you used to working with these Pythagorean identities. Now, 1 over the sine squared, I don't think they want you to plug 1 over sine squared. I don't think they want you to plug in for sine squared 1 plus cotangent squared theta. I think what they want you to do is they want you to rewrite this. 1 over sine of theta is cosecant. So 1 over sine squared of theta is cosecant squared theta. Now I'm guessing that most likely that's what he wants there. But I guess you could plug in, I wouldn't do it, but in for cosecant squared theta you could plug this in, but that's a little bulkier, so typically we want to try to simplify when we can. Very similarly, look at this guy up here. 1 over cosine squared theta, that's equal to the, now 1 over cosine is the secant of theta, so that's equal to secant squared theta. And again, we could make a substitution, but I'm not messing with it. Now it gets a little interesting because they threw a negative in front of cosecant squared theta. Let's go down to here. Do you see where cosecant squared theta is? Well, this is the opposite. Negative, opposite that. So I've got to take the opposite of this side. So this would be negative cotangent squared theta minus 1. It's like you multiplied both sides through here by negative 1. Now here's another one where I would probably just go ahead and do the reciprocal relationship, this guy as well. 1 over cotangent squared theta. Now I just said that 1 over the cotangent of theta is tangent, so this is the same as tangent squared theta. And I don't think I'm going to make any kind of a substitution like that. I'm guessing that's probably what he wants. Now secant squared theta minus 1, I think we've got that guy. There he is. Secant squared theta minus 1. It's equal to tangent squared theta. Tangent squared theta. Very nice. 1 over the tangent of theta. We said that cotangent is 1 over the tangent of theta. So this is equal to the cotangent of theta. And that's probably as simple as he wants it there as well. We got 3 to go. 1 minus cosecant squared theta. Now we don't have that here. We have cosecant squared theta minus 1. That's 1 minus cosecant squared theta. That's the opposite. See, if I multiply by negative 1, I'd get that. So if I'm multiplying this by negative 1, I'm taking this by negative 1, so I get negative cotangent squared theta. That might be the trickiest one there because of the little negative 1 trick. Now, the last two look to be the most complicated, and they turn out to simplify very nicely. Look at the denominator. Sine squared theta plus cosine squared theta. I know I have cosine squared theta plus sine squared theta. Same thing. This is equal to 1. So this is the sine of theta over 1, or just the sine of theta. And there's my answer. Okay? Oh, I haven't been underlining my answers, have I? There we go. Now they're underlined. And one more to go. Cosine theta over secant squared theta minus tangent squared theta. Well, let's see. That denominator looks interesting. Secants and tangents. Look in the middle here. Look at this guy right here. Secant squared theta minus tangent squared theta right here. It's equal to 1. So this is the cosine of theta over 1, or the cosine of theta. Okay. Now I don't think that this lesson is all that difficult, but it does take a little bit of practice, and you will need to remember your Pythagorean identities and then be able to find the variations of them. So with the extra time that normally you'd be spending on math, I would go back, I would review the unit circle, make sure you feel comfortable with that. Look over the graphs, because you're going to have a lot of trig on your semester exam. Look over the graphs of sine and cosine and tangent. You know, when is it positive, when is it negative, reference angles, coterminal angles, things like that. Because you've got a little extra time, let's keep that information from the first part of the fourth quarter in our heads, as well as this new stuff that we're looking at today.